Okay, this is a video about functions and their inverses. So in this section, we're just going to understand what a function and its inverse do. So first is the notation of an inverse function. So you've probably seen this before, but this is the notation. F inverse of x reads F inverse of x. It does not mean, F inverse of x does not mean the reciprocal of f of x. This is not what this means. It's a new notation. So we'll know that that is not what we're talking about. So just as a really quick illustration of what a function and its inverse do, here is the function box that you've probably seen before, where what you do is you feed the input into the function box and it gets operated on and an output comes out. So the input into function is what we call the domain. And so we would put some x value into this, our domain. It would get operated on, and what comes out of this is f of x. And then sometimes we've talked about a composition of a function of a function. So if we feed this down the conveyor belt, and so the output of this gets fed into a new function here, maybe called g. So what got fed into g was not x, but f of x is what went into there. F of x gets fed in. Then what comes out is not g of x, but g of f of x. Like that. Okay, so this is called, in this instance, this would be called g of f of x, or g of f of x. Okay, so let's make up a function. I'm going to make up a function called, I'm going to add the number 7 to whatever comes in the domain that comes in. So right here, here's my function f. I'm going to call it x plus 7. So now let's make up an inverse. What would completely undo that operation? What would undo adding 7 to something? Well, subtracting 7 would undo that. So let's make up our inverse function over here called x minus 7. Okay, so just to illustrate this fully, let's pick some value for x. If my function's x plus 7, the domain of this function, which is a linear function, would be all real numbers. So let's pick a number, and I'm going to choose number 11. So let's just say I feed 11 into this. 11 goes into the box. See, he's right there. 11 plus 7 is 18. 18 pops out. And so now 18 gets fed down the conveyor belt. And this is 18 right here. He's popping in here. And now he's this x. And 18 minus 7 gives me 11. So what we find here, okay, this was function g, is when you take a function, and it's not just any old function g, but it's a special function called f inverse, the inverse of x, not g, but the special function f inverse of x. When you put in x, you operate on him, you unoperate on him, you get out the original value that you put in, 11. So when we don't have g, but some special function, f inverse, the inverse, f inverse of f of x gives us x. And also the other way around. F of f inverse of x gives us the original input. So we're going to see this, we're going to illustrate this some more, but that's basically what a function and its inverse do. They undo each other. So that's the first characteristic that we see of a function and its inverse. We'll look at this further in the second video. Right now I want to go ahead and illustrate the graphs of these functions, what they do. The graph of a function f and its inverse, f inverse of x, they reflect across the line y equals to x. So I want to illustrate that one. First, I'm going to make up a function that I know has an inverse. By the way, all functions do not have an inverse, and we will see that as well. But for now, I just want to make up a function so we can see this illustrated. If I've got this function f of x, which is equal to x plus 1 cubed minus 2. Let's say we've got that one. X plus 3, x plus 1 cubed minus 2. It has an inverse. So just 1 second while I figure out what the inverse is. Okay, so f inverse is going to be the cube root of x plus 2 minus 1. That's what his inverse is going to be. Now, I did not tell you how to find the inverse right now, but I will tell you how to in a minute. So for right now, I just want us to explore what the graphs do. So if I have some graph, some xy coordinate right here. Okay, let's graph f. And so when I graph f, I'm going to graph him in red. We're going to make this guy red so we can see him, f of x. And then f inverse of x, I'll do this one in green. Okay. We'll have a little Christmas theme going on, f inverse. All right, so if you will recall with me, x plus 1 cubed minus 2 is a transformation of a basic graph x cubed. So x cubed, if nothing's going on with them, he sort of looks like this. He sort of has that look to him. So I'm going to graph that on here. But this is a horizontal transition. This is going to go to the left 1. It's in there messing with the x. It's opposite of what it appears to be, down 2. Down 2. So if I go left 1, down 2, this is going to be my new xy axis, so to speak. So I'm going to graph my x cubed on here. Let's see. If I go up 1, right 1, if I go down 1, left 1, he's going to look like this, basically. He's going to come in here, and he's going to snake up here like this. Something like that is what he looks like. So that is my f. All right, so let's put g on there. This is the cube root of x plus 2 minus 1. I don't actually need this parentheses because it's underneath this cube root. So that is like it's a grouping already. This is a transformation of the basic function, the cube root of x. And so this guy looks like this, sort of. Kind of comes in there like that. So this is going to go to the left 2, horizontal, opposite of what it appears to be, down 1. Vertical shift is what it appears to be. So if we go left 2, down 1, down 1. This is my new xy axis right there. Okay, so if I put this new cube root of x, he will look like this. He's going to sort of snake in here like this. He's going to come increasing, and he's going to come like this. That's what he's going to look like. Let me see if I can do a better job on this end. Okay. That is what f inverse looks like. Okay, now, then we have this statement here that a graph and its inverse will reflect across the line y equals to x. So let's have a look at that. The line y equals to x, if I write this, y equals mx plus b. This is a slope-intercept form, so I see the y-intercept here is 0. There's nothing there. So it passes through the point 0, 0, and there's a 1 in front of that x, so the slope is 1 over 1. So let's graph this line. 0, 0, up 1, right 1, right there. Okay, so here we go. Let us graph that line on here. This is what the line y equals to x looks like. Now, every function and its inverse will reflect across that line. So that means basically, if you think of this as a piece of paper and you folded it across that dotted line, the red and the green would touch everywhere when they fold it across. So you can kind of see that. These arrows would come up and touch. These points would come up and touch. Everywhere they would touch. So that's what number 3 is trying to illustrate. Number 2, let's look at that. The domain of one is the range of the other and vice versa. Let us identify a point on here, okay? Let's identify this point right here. This point in black right here, this is the point 1, 1, okay? Let's look at this point, this red point right here. What point is this? The coordinates of this one. Well, see, this guy got shifted left 1, down 2, left 1, down 2. This is the point right here, -1, -2, all right? What is this green point right there? Let's see if we can figure that out. We went left 2, down 1. That's -2, -1. Let's see, -2, -1. Okay, so let's just see. X stands for domain, Y stands for range. This statement is saying that the domain and the range will be switched for f and f inverse of x. So right here, This x is -2, but he's the y of this point. And this y is -1, but he's the x of this point. See how that got switched? That's true for that point and for every other point on here. Here's a point where they share. The x and the y are reversed, but they're the same thing. That's why that's working there. How about this point right here? Let's look at these intercepts. Does it work right here? This point is the point 0, -1, and this point right here is the point -1, 0. The domain is the range of the other and the vice versa. So it works for those 3 points, but it's going to work for every single point on every part of each of these graphs. They will always be switched. So the domain of one is the range of the other for every single point. Okay, so that's kind of the 3 characteristics I wanted to point out. Now we're going to go to the worksheet.